Our world of factories and assembly lines feels uniquely modern, but the idea of mass production is ancient. Across the globe, hidden in plain sight, are the silent workshops of forgotten industries. We are about to explore 30 of them. By the end of this journey, you will see the ancient world not as a place of simple crafts, but as a landscape humming with coordinated, large-scale manufacturing. The evidence is not in dusty manuscripts, but in the earth itself, mountains of discarded shells, rivers of industrial waste, cities of kilns, all speaking a language of staggering scale. What logistical secrets did these civilizations master to feed their empires? How did they organize thousands of hands without a single spreadsheet? We will walk through the physical remains that hold the answers. What does it mean for our story of human progress when we find a factory that is 2,000 years old? That journey begins on a sun-baked stretch of Mediterranean coastline, with a color so rare it became a legend. To produce just a single gram of true Tyrian purple dye required the careful harvesting of roughly 10,000 murex sea snails. Now picture not a handful of shells, but entire artificial hills made of them, towering over the ancient harbors of Tyre and Sidon. Archaeologists call these formations middens, but that clinical term fails to capture their staggering reality. These are mountains of industrial waste, centuries deep, composed of countless millions of crushed snail shells. This is not the debris of a small craft workshop. This is the unmistakable signature of a factory, and its product was worth more than its weight in silver. The process itself was a foul and precise alchemy. The precious gland was extracted from each snail, then soaked in massive, rank vats for days. The liquid would ferment, shifting through a spectrum of colors from green to blue until, finally, it settled into that deep, vibrant purple that would not fade. The remains of these vats, along with crushing floors stained with millennia-old residue, tell a story of coordinated labor. The stench from these operations was said to be unbearable, pushing the dye works outside the city walls, yet the output was so valuable it shaped empires. This was a state monopoly, a protected secret. The scale of the shell middens tells us this was not artisanal work, but systematic, large-scale harvesting and processing, an entire coastal economy built on satisfying a single, elite desire. From these Phoenician ports, small bolts of purple-dyed wool traveled across the known world, becoming the ultimate status symbol for Roman senators and Byzantine emperors. Every purple border on a toga, every royal robe began here, in these mountains of shattered shell, a testament to an ancient industry that understood the power of branding and exclusivity long before the modern world. But that legendary purple was for the robes of emperors, for the everyday tables of the empire, from the villas of Britain to the outposts of Syria. There was another signature product, one made not for the few but for the many. In the rolling hills of central Italy, near modern Arezzo, the ground holds the remnants of a different kind of factory. Here, the Romans perfected the art of mass-producing beauty. They called these workshops figlinae, and they turned pottery from a local craft into the first truly global brand. The evidence is in the very earth, a sprawling industrial park of ancient production. Archaeologists have uncovered vast complexes of kilns, not just one or two, but entire neighborhoods of them, each capable of firing hundreds, even thousands of identical ceramic bowls, plates, and cups in a single cycle. This was not potters working alone at individual wheels. This was a coordinated assembly line of clay. The secret to their staggering output was standardization. They used master molds, often made of plaster, into which liquid clay or slip was poured. A single, finely carved mold could be used to produce countless perfect copies of a detailed bowl, decorated with intricate patterns of leaves, gods, or geometric designs. This meant that a skilled artisan only needed to create the original model once. After that, teams of less specialized workers could pour the clay, manage the drying, and oversee the firing, producing vast quantities of identical high-quality ware. The division of labor was precise. Some workers mined and refined the local red clay. Others operated the potter's wheels for simpler forms. Teams managed the molding and detailing, while true experts controlled the monumental kilns, mastering the exact temperatures needed to produce that distinctive, glossy red finish known as a retine ware. The scale is humbling. These workshops were not hidden away. They were the engine of the local economy, their products packed into ships and carts to flow along Roman trade routes. Finding a piece of this polished red pottery in an excavation in France, North Africa, or the Middle East is so common it barely registers as a surprise to archaeologists. That is the ultimate proof of its industrial nature. Its identical patterns and forms speak of centralized production for a dispersed, empire-wide market. It was the disposable dishware of the Roman world, affordable, durable, and stylish, proving that the Industrial Revolution did not invent mass production. It merely rediscovered a principle the Romans had mastered 2,000 years prior. The red glazed pottery of Rome traveled across continents, a tangible symbol of imperial commerce. But another ancient industry, far across the Atlantic, dealt in a material valued not for its utility but for its soul. In the steamy lowlands of Mexico's Gulf Coast, the Olmec civilization, often called the mother culture of Mesoamerica, established a different kind of industrial hub, one dedicated entirely to jade. The archaeological site of La Venta reveals not just a ceremonial center, but the beating heart of a vast and controlled production network. Here, researchers have uncovered workshops that speak of specialization and staggering output. The floors of these ancient ateliers were littered with specialized toolkits, stone saws for cutting blocks, hollow reed drills for boring holes, and abrasive sands for polishing the final pieces to a brilliant, watery sheen. More telling than the tools, however, was the sheer volume of material left behind. Piles of raw, unworked jade cobbles, transported from sources hundreds of miles away in the mountainous regions of modern-day Guatemala, lay alongside mountains of production waste, countless fragments and flawed pieces discarded in the process. This scale of operation points decisively away from individual artisans working on commission. This was a centralized, state-directed industry. The Olmec elite, who associated jade with maize, water, and life force, required a constant supply of ritual objects, ceremonial axes, and intricate figurines to demonstrate their divine connection and political authority. The workshops of La Venta were the factory floor that met this demand. The organization required was immense, managing long-distance trade for the raw stone, housing and feeding skilled craftspeople, and controlling the distribution of the finished sacred objects. Each polished celts or hauntingly beautiful jade mask was more than an ornament. It was a solidified piece of power, produced not one at a time, but in coordinated batches to uphold an entire cosmology of rule. The waste itself is the clearest evidence, a silent testament to the volume of work and the high standards of an industry that turned earth stone into the ultimate symbol of spiritual and political authority. While the Olmec turned stone into symbols of the soul, the Romans perfected the art of turning earth into empire. A simple, fired clay brick seems like the most humble of objects, yet in ancient Rome, it became a unit of industrial accountability. Along the banks of the Tyre River, the landscape was once dotted with vast, smoky brickyards, and it is here that we find one of history's most transparent records of mass production, stamped literally into the building blocks of the world. The Romans did not just make bricks, they logged them. Each brick, before it was fired, received an impression from a wooden stamp. This was not a maker's mark for pride, it was a factory tag for control. A typical stamp might read something like, "From the brickyards of Domitia Lucilla, estate of Figlinae, shift of Marcus." In that one imprint, you have the owner of the industrial operation, the specific factory location, and even the foreman or work crew responsible for that batch. This was a supply chain management system carved in clay. The physical remains of these Tyre Valley brickyards reveal the scale this system was built to handle. Archaeologists find not isolated kilns, but organized industrial zones with multiple massive firing chambers, drying sheds, and yards for stacking the standardized products. The bricks themselves were made to consistent sizes, the most common being about 1.5 feet long, a concept we might call a modular building unit. This standardization was crucial. It meant a brick fired in a yard north of Rome would fit perfectly alongside one from the south, allowing for the seamless construction of colossal projects by armies of laborers who did not need to cut or trim each piece. Now consider the demand. A single imperial project like the Baths of Caracalla, a sprawling leisure complex, required an estimated 6.5 million of these bricks just for its central structures. The Aurelian walls, the defensive girdle thrown around Rome in the late 3rd century, consumed millions more. This was a demand that could only be met by an industry, not a craft. The stamped brick system was the ingenious solution. It allowed the imperial administration, or wealthy private contractors like Domitia Lucilla, who was actually the mother of Emperor Marcus Aurelius, to oversee quality and output across a decentralized network of production sites. If a batch of bricks failed or a wall showed defects, the stamp told you exactly where to send the complaint. It created a chain of responsibility from the shift worker at the kiln to the soaring vault of an imperial bathhouse. This logistical miracle transformed the very fabric of the empire. Those small, stamped pieces of clay were the silent, multiplying cells that built the monumental skeleton of Roman cities from Britain to Syria. They tell us that behind the grandeur of arches and aqueducts was a paperwork revolution, a system of industrial tracking so effective that we can still read its memos, fired hard and immortal 2,000 years later. The stamped bricks of Rome built an empire of stone and order, but another ancient industry dealt in something far more ephemeral, the capture of scent itself. On the sun-drenched island of Cyprus, at a site known as Pyrgos, archaeologists uncovered a different kind of factory floor, one dedicated not to construction but to allure. Here, in a complex dating back over 4,000 years, they found the world's oldest known perfume laboratory. The scene was preserved almost as if the workers had just stepped away. Dozens of specialized vessels told a clear story. There were bulbous distillation stills made of local clay, their design sophisticated for their time, used to extract essential oils from delicate petals. Nearby sat rows of mixing vats for blending these oils with olive oil as a base, and an array of small, finely made storage flasks ready to hold the finished, precious liquid. This was not a corner of a home where perfumes were occasionally made. The layout reveals a deliberate, scaled operation. The number and uniformity of the equipment point to standardized recipes and a repeatable process, the hallmarks of batch production. Imagine the sensory atmosphere of this place, the air thick with the simmering fragrance of local flowers like lavender, rosemary, rose, and myrtle, harvested from the Cypriot hillside. The Minoans, the sophisticated Bronze Age civilization centered on Crete, were masters of trade across the eastern Mediterranean. The perfume factory at Pyrgos, likely a Minoan outpost, was a strategic industrial asset. It transformed the island's natural bounty into a highly concentrated, non-perishable luxury good, perfect for long sea voyages. Small, sealed flasks of Cypriot perfume could be shipped to elite customers in Egypt, Anatolia, and the Greek mainland, carrying with them the essence of a distant island. The scale of the facility, with its dedicated workspaces for each stage of production, suggests this was a commercial enterprise of significant importance. It tells us that the desire for personal fragrance, for an invisible marker of status and identity, was powerful enough 4 millennia ago to justify building what we can only call a factory, turning fleeting blossoms into one of the ancient world's most portable and profitable forms of wealth. The fragrant oils of Cyprus were traded for pleasure, but the most disciplined factories of the ancient world were built for a singular purpose: power. In the dry earth of central China, not far from the silent ranks of the terracotta army, archaeologists uncovered a different kind of army, one made of metal and machinery. The pits containing the thousands of clay soldiers are world famous, but the true revelation lies in the scattered workshop remains nearby, the imperial armories of the Qin dynasty. Here, the first emperor of a unified China did not just commission statues, he industrialized warfare itself. The evidence is in the smallest of components, the bronze trigger mechanisms for crossbows found by the thousands. Each trigger is a complex assembly of several interlocking parts, a tiny machine of levers and catches. When researchers began to examine these parts, they made a stunning discovery. The individual components, the sears, the bolts, the safety catches, were not unique to their specific trigger. They were manufactured to such an exacting, universal standard that a part from one crossbow could be removed and fitted perfectly into the mechanism of another. This was the ancient world's version of interchangeable parts, a concept we associate with the Industrial Revolution over 2,000 years later. This was not the work of individual blacksmiths taking pride in unique creations. This was a state-mandated, ruthlessly efficient production system. The workshops were organized assembly lines. One set of craftsmen would have been responsible for creating the master molds, likely from clay or stone. Another group would handle the pouring of the molten bronze into these molds. Yet another team would finish the rough castings, filing and polishing them to the precise dimensions required. Finally, assemblers would take bins of these standardized parts and fit them together into complete, functional triggers. The scale speaks of a staggering output, designed to equip a military machine of hundreds of thousands of soldiers. This system solved a critical logistical problem for the Qin emperor. On a distant battlefield, a broken crossbow could be repaired not by a skilled armorer, but by any soldier with a spare parts kit, simply swapping out the failed component. It turned weapon maintenance from a craft into a simple, repeatable procedure. The uniformity of these bronze pieces is a physical manifesto of Qin philosophy, one of absolute control, standardization, and centralized authority applied to the very tools of conquest. The silent, assembled terracotta warriors show us the emperor's ambition, but these small, interchangeable bits of bronze show us the cold, systematic genius that made that ambition possible, the factory logic that built an empire. The Qin armories achieved precision through rigid standardization, a philosophy of control cast in bronze. But another ancient industry pursued a different kind of magic, one that captured the shimmer of the sky in a humble piece of earth. In the sun-bleached ruins of Tel el Amarna, the short-lived capital of the rebel pharaoh Akhenaten, archaeologists uncovered an entire industrial district dedicated to this alchemy. Here, row upon row of kilns and workshops were not making tools or weapons. They were manufacturing light and color itself, producing a material the Egyptians called tijahanet, what we know as faience. This was not simple pottery, but a glazed quartz ceramic, a brilliant glass-like substance that could be formed into beads, amulets, and dazzling tiles of lapis lazuli blue or turquoise green. The layout of the Amarna workshops reveals a production line as deliberate as any modern factory. In one area, workers would have been grinding quartz sand into a fine powder, the base material. In another, specialists mixed the secret glazes, compounds of copper and alkali that would fuse into that iconic, luminous color during firing. The heart of the operation, however, was the forming room. Here, artisans did not sculpt each tiny amulet or bead by hand. Instead, they used molds. Archaeologists have found countless plaster molds, each one a negative impression for a popular shape: a wedge-at eye, a scarab beetle, a fertility figurine. Workers would press the damp quartz paste into these molds, creating perfect, identical copies by the hundreds. Once dried, these objects were moved to the banks of kilns for firing, a delicate process that transformed the dull paste into a gleaming, vitrified treasure. The scale is what defines this as industrial craft. The demand was immense, for faience was the plastic of the ancient Egyptian world. It was used for everything from the jewelry of commoners to the wall tiles that lined royal palaces, simulating the precious stones the pharaoh desired. Akhenaten's radical new capital, built from nothing in the desert, needed vast quantities of these symbolic objects to adorn its temples and homes, to literally fill the city with divine light and color. The separate, dedicated zones for each stage of production, mixing, molding, glazing, and firing, tell us this was a streamlined, high-output operation. It was a state-sponsored industry of beauty, turning desert sand into the physical manifestation of the sun god Aten's rays, proving that mass production in the ancient world was not only for the practical, but often for the profoundly spiritual. The gleaming faience of Egypt was a product of royal decree, but in the cold mists of the north, a different kind of factory thrived on pure commerce. In the Viking Age trading town of Ribe, Denmark, the ground tells a story not of pharaohs but of entrepreneurs. Excavations here have revealed something extraordinary, not a single craftsman's hut, but entire districts dedicated to one precise, glittering product: glass beads. In concentrated workshop plots, archaeologists have unearthed a specific kind of industrial debris: thick layers of ash, countless fragments of small clay crucibles, and most tellingly, thousands of half-finished, broken, or discarded beads alongside raw chunks of colored glass known as cullet. This is the physical evidence of a production line. The crucibles, tiny vessels just a few inches across, were the furnaces of this industry. A bead maker would place a sliver of glass cullet, often recycled from broken Roman mosaics or vessels traded from the south, into the crucible and heat it in a furnace until it became a molten droplet. Using a metal rod, they would then wind the glass into a bead, often adding trails of contrasting color for intricate patterns. What makes Ribe an industrial site is the sheer density of this activity. The finds are not scattered but clustered in specific zones, suggesting dedicated, organized workshops operating side by side. The variety of styles is vast, but within each style, the beads show remarkable consistency, pointing to standardized techniques and perhaps even master molds for popular designs. This was not about creating unique heirlooms, it was about satisfying a massive, hungry market. The Viking trade networks stretched from Dublin to Constantinople, and beads were a universal currency of adornment and status. A trader arriving in Ribe could commission or purchase hundreds of identical, fashionable beads to be traded for furs in Sweden or silver in the Baltic. The scale of production hints at a seasonal, almost factory-like operation, where craftsmen worked intensively during trading seasons to build up inventory. The workshops of Ribe were a furnace of globalization, melting down the legacy of the old Roman world to create the portable, desirable wealth that fueled the Norse age of exploration and exchange. From the fiery forges of Viking Ribe, we travel millennia back and continents away to a river valley where mass production achieved an almost inhuman level of precision. The cities of the Indus Valley civilization, like Mohenjo-Daro and Harappa, are famed for their startling urban planning, but their true industrial genius is revealed in smaller, quieter sites like Lothal and Chanhudaro. Here, the factories did not produce weapons or pottery, but something far more delicate: tiny masterpieces of light and stone. The workshops of these cities were dedicated to carnelian, a hard, blood-red gemstone coveted across the ancient world. The archaeological footprint is unmistakable. Entire city blocks were given over to this single craft. You find courtyards piled high with the raw material, thousands of rough, rust-colored carnelian nodules gathered from distant sources. Nearby are the grinding stones and abrasives used to shape these rough stones into perfect, identical barrels and cylinders. But the most telling evidence lies in the waste, immense heaps of broken, half-finished and discarded beads, a literal mountain of trial and error that speaks of relentless high-volume output. The true marvel, however, is the tool that made this scale possible, the specialized drill. These were not simple copper points. They were ingenious composite tools with a thin, durable tip made of a harder stone called chert, fastened to a copper rod. This chert tip, often just a millimeter or two wide, was the key. It allowed artisans to bore perfectly straight, microscopic holes through the incredibly hard carnelian, a process that could take days for a single, long bead. To achieve this, they built bow-driven lathes. A craftsman would secure the bead, set the drill point, and then saw a bow back and forth, spinning the drill with a steady, relentless rhythm. It was an act of immense patience and skill, repeated not hundreds but millions of times. The standardization is what shocks the modern observer. Beads recovered from these sites and from distant Mesopotamia are identical in size, shape, and the perfection of their piercing. This was not artistic expression, it was industrial specification. These tiny red stones were a form of concentrated wealth, traded through the vast Indus network and beyond. A single, perfectly drilled carnelian bead found in the royal tombs of in Mesopotamia tells a story of continents connected by supply chains, of workshops in Lothal producing for a market they would never see. The heaps of waste are not signs of failure, but of a system so rigorous that only flawless products were allowed to leave the factory floor. It was an industry built on the mastery of friction, time, and geometry, producing millions of units of beauty so standardized they became a universal currency. The blood-red carnelian beads of the Indus were a currency of beauty, but the true engine of an ancient economy often lay hidden underground, in the raw material itself. Far from the bustling workshops, the most brutal forms of industrial-scale production were dedicated to extraction. Southeast of Athens, in the dry, rocky hills of the Laurion region, the earth still bears the scars of a machine that minted an empire. This was not a factory of artisans, but a sprawling, subterranean city of labor dedicated to a single element, silver. The landscape here is pockmarked with over 2,000 vertical shafts, some plunging down more than 300 feet into the darkness. These were not simple holes, but the access points to a vast, branching network of tunnels and galleries, a man-made hive following the thin, precious veins of lead ore that held the silver within it. Above ground, the industrial remains are just as staggering. Vast, paved ore washing floors stretch across the hillsides, intricate systems of channels and basins where crushed rock was flushed with water to separate the heavier, silver-bearing material from the worthless stone. Nearby, the foundations of hundreds of smelting furnaces lie in rows, their stones still blackened by soot and heat. This entire complex was a single, integrated production line on a colossal scale, from the miners chipping at the rock face in airless galleries, to the washers sorting the ore under the sun, to the smelters tending the roaring fires that finally liberated the gleaming metal. The operation was a triumph of organized logistics, but it was powered by an immense human cost, relying on the labor of thousands of individuals in conditions of great hardship. The wealth it generated, however, was the direct fuel for a historic explosion of culture. The silver of Laurion was struck into the famous Athenian owl coins, the reliable currency that greased the trade of the Aegean. More crucially, this stream of bullion financed the construction of the Athenian navy, the very fleet that defeated the Persian invasion at Salamis and secured Athenian dominance. It paid for the Parthenon, for the dramas of Sophocles, for the philosophy of Socrates. The entire Athenian Golden Age, that luminous moment which so defines our idea of classical civilization, was underwritten by the relentless, grinding industry of these sun-scorched hills. The beautiful artifacts and grand monuments we admire were the final product, but their foundation was this: a dark, dangerous, and meticulously organized factory in the earth. The silver of Laurion financed an empire of light and philosophy, but another ancient city built its power on a far sharper foundation. In the high valley of central Mexico, the vast metropolis of Teotihuacan, with its towering pyramid of the sun, was not just a ceremonial center, it was a meticulously planned industrial machine. And its most vital industry was forged from volcanic glass. Within the city's rigid grid, archaeologists have uncovered entire districts that functioned as factory neighborhoods, with the most concentrated evidence found in the monumental Ciudadela complex. Here, the ground is not simply littered with a few stone chips, it is paved with them. Walking through these excavated workshops, you crunch across a carpet of obsidian that is inches deep in places, a glittering black sea of shattered stone. This is not the occasional tool-making debris of a household, but the systematic waste of full-time, high-volume production. The scale is conveyed in the categories of finds. There are piles of prepared cores, the fist-sized nodules of raw obsidian from which blades were struck. There are heaps of pristine, razor-sharp blades, thousands upon thousands of them, nearly identical in size and form, stacked like unused stock in a warehouse. And everywhere there are the waste flakes, the smaller shards and misstruck pieces, amounting to many tons of material in a single workshop district. This level of output tells us this was not a craft, but a centrally controlled industry. Obsidian was the steel of ancient Mesoamerica, the essential material for everyday cutting tools, ritual bloodletters, and formidable weapons like the macuahuitl, a wooden sword edged with these lethal glass blades. Teotihuacan sat near some of the region's richest obsidian sources, and its rulers understood that controlling this resource meant controlling the economy. The workshops in the Ciudadela, positioned right next to the city's main temple and administrative precinct, were likely state-run operations. Artisans here would have been specialists, mastering the precise percussion technique needed to strike a long, perfect blade from a core with a single, skillful tap. The sheer volume of identical blades suggests a staggering level of standardization, a production line where workers focused on a single, repetitive step to maximize output. This organized industry supplied the entire city of perhaps 100,000 inhabitants with their essential tools, and also produced a massive surplus for trade. Teotihuacan's influence stretched across the continent, and its most potent export may well have been these bundles of black glass blades, a tangible product of the city's industrial might. The pyramids awe us with their scale, but it was this gritty, relentless factory floor, shimmering with volcanic glass, that provided the sharp, practical edge upon which Teotihuacan's civilization truly rested. A city's grandeur is measured not only by its monuments, but by its most mundane necessities. In the shadow of Pompeii's grand forum and villas, tucked into its bustling streets, lay an industry dedicated to the very fabric of Roman life. The Fullonicae were far more than simple laundries. They were sprawling, multi-stage factories for cleaning, finishing, and revitalizing woolen cloth. Stepping into the ruins of a large Fullonica, like the famous fullery of Stephanus, is to walk through a preserved industrial flowchart. The process began in a series of deep, interconnected vats. In the first, soiled garments and raw woolen cloth were soaked in a mixture of water and a rather pungent cleansing agent, fermented human urine collected from public latrines. The ammonia in the urine acted as a powerful degreaser, breaking down oils and dirt. From there, the cloth moved to the most distinctive area, the treading stalls. Here, workers, often standing waist-deep in the liquid, would stomp and knead the cloth with their feet for hours, mechanically agitating the fibers to lift out the grime. This was not a gentle wash, it was a physically demanding industrial process. After treading, the cloth passed through a sequence of rinsing vats with progressively cleaner water, before being taken to press rooms where it was stretched, brushed with fine clay or fuller's earth to absorb residues, and then meticulously combed to raise the nap. Finally, it was hung in vast, multi-story drying courtyards. The scale of these operations is what defines them as factories. The largest Fullonica in Pompeii could process hundreds of garments and bolts of cloth simultaneously, serving not just individual households, but the entire city's textile trade, from the togas of the elite to the tunics of soldiers and slaves. The smell, as you might guess, was infamous, leading to regulations that often placed these establishments on the edges of residential districts. Yet this malodorous, regulated industry was indispensable. It turned a basic necessity, cleaning, into a standardized, high-volume service, proving that even the most ordinary aspects of daily life in the ancient world could be organized on a truly industrial scale. The sharp, practical edge of obsidian gave way to a far more subtle form of power, one measured in drops and fragrance. In the storied palace of Nestor at Pylos, a different kind of record-keeping reveals an industry of the senses. Here, fire did not forge weapons but liberated scent. The key evidence comes not only from archaeology but from words. The palace's administrative archives, written in the ancient script known as Linear B on clay tablets, provide a stunningly precise ledger of this aromatic enterprise. These are not epic poems but inventory lists, and they detail allocations on a staggering scale. One tablet records over 600 liters of olive oil being issued to a perfumer named Tyre. Another lists vast quantities of specific herbs and spices, coriander, cyperus, rose, and saffron, meticulously weighed out and assigned to different workshops. This is the paperwork of a state-run factory. The physical remains at Pylos bring these dry lists to life. Archaeologists have uncovered specialized workshop areas containing rows of massive storage jars called pithoi, capable of holding the oil mentioned in the tablets. More telling are the installations for heating, sets of clay basins set into benches with spaces beneath for fires. This setup was for a careful, controlled process known as enfleurage or low-temperature simmering. Workers would gently heat the oil in these basins with the precious botanicals steeping inside, allowing the fat to absorb the volatile essences over days, creating a perfumed unguent. The standardization implied by the Linear B records, with specific recipes tied to specific oil and spice quantities, points to a repeatable, quality-controlled product. This was not a hobby, it was a palace-controlled industry with a clear purpose. The scented oils produced here served multiple vital functions. They were used in elite daily grooming, a marker of status and civilization. They were essential in religious rituals, anointing statues and participants, filling sacred spaces with a pleasing aroma for the gods, and critically, they were a high-value trade commodity. Sealed in elegant stirrup jars, these perfumed oils could be shipped across the Mediterranean, carrying the name and prestige of the Mycenaean palace to distant shores. The factory at Pylos was a nexus where agriculture, bureaucracy, and craft converged to manufacture not just a luxury, but a liquid form of social and divine currency, its recipes as closely guarded as any state secret. The perfumed oils of Pylos were a luxury measured in drops, but the industrial heartbeat of another empire was measured in the thunderous flow of molten metal. In the northern Chinese province of Hebei, the landscape still holds the fossilized remains of a production force so vast it reshaped an entire civilization. During the 11th century, under the technologically brilliant Song dynasty, this region became the steel belt of the ancient world. The archaeological sites here, like those at Guantai and Siju, are not simple forges. they are the skeletons of fully integrated industrial complexes. Walk through these ruins and you are navigating a carefully planned factory floor, centuries ahead of its time. The most striking features are the massive blast furnaces, built of stone and refractory clay, some standing nearly 20 feet tall. These were not fueled by simple charcoal, but by coke, a purified form of coal. The Song engineers had mastered the process of baking coal to drive off impurities, creating a fuel that burned hotter, cleaner, and more efficiently than anything used in the West for another 700 years. This innovation alone represents an industrial leap. Surrounding these furnaces are the foundations of foundries and hammer forges, where the raw pig iron was refined and shaped. The entire operation was a coordinated symphony of extraction, processing, and manufacturing, and the output numbers preserved in imperial records are almost difficult to comprehend. At its peak, this northern complex was producing tens of thousands of tons of iron annually. To grasp that scale, consider that the entire output of 18th century Britain, on the eve of its own industrial revolution, was only around 25,000 tons. The Song were operating at that level in the 11th century. This river of iron flowed into every artery of the empire. It was hammered into the plowshares that opened up new agricultural frontiers, into the nails and brackets that held together sophisticated wooden architecture, and into the thin, resilient armor of the Song military. It was cast into coins by the millions, stabilizing a monetary economy of unprecedented complexity. Most astonishingly, this iron was produced not for a handful of elite projects, but for a booming commercial market. Farmers could purchase standardized iron tools from government depots, and private foundries competed in a vibrant, regulated industry. This was a true industrial revolution in everything but name. A national economy powered by coordinated, high-temperature factories that turned stone and fire into the very skeleton of progress. The scale is a silent rebuke to the idea that mass production was a European invention, revealing instead a moment in history when China stood on the brink of an industrial age all its own. The Song dynasty's ironworks roared with the heat of progress, but in the silent desert canyons of Jordan, another civilization built its industry not on fire, but on the capture of a single, more precious element. Petra's rose-red cliffs are famous for their carved facades, but the city's true genius lies in what you cannot see at first glance: a hidden, city-wide factory dedicated to manufacturing water itself. This was not a craft, but a continuous, industrial-scale effort of hydraulic engineering, and its most telling artifacts are not monuments, but miles of humble ceramic pipe. Scattered across the Petra Basin, archaeologists have identified specific workshop areas littered with the evidence of this vital industry. Here, they find not the occasional broken pot, but concentrated deposits of pipe fragments, all in standardized diameters, alongside the remains of kilns specifically sized to fire these long, cylindrical sections. The Nabateans did not simply dig channels, they mass-produced a pressurized delivery system. Each pipe section was thrown on a wheel to a precise thickness and dimension, designed to fit snugly into the next, sealed with a waterproof mortar. The scale of production required was immense, for this network was the city's circulatory system. From distant springs in the surrounding mountains, water was channeled into a master reservoir, the Syk, and from there, it was distributed through this manufactured pipeline to public fountains, private villas, and the vast garden terraces of the city center. Maintenance was a constant industrial effort. Teams of workers would have patrolled the lines, replacing cracked sections from stockpiles of identical pipes produced in the city's workshops. This was a logistics operation as critical as any army's supply train. In a desert environment where annual rainfall could be catastrophic and brief, this manufactured system did more than provide drinking water, it created predictability. It allowed Petra to flourish as a hub for tens of thousands of people, and the countless caravan camels that were the source of its wealth. The workshops that produced those endless ceramic pipes were the unsung engine room of the entire Nabatean kingdom, turning fragile clay into a relentless, controlled flow that defied the desert, an industry whose product was not a thing to be traded, but the very condition of life. The relentless flow of water in Petra sustained a desert capital, but halfway across the world, a different kind of currency flowed from a river. In the fertile floodplain where the Mississippi and Missouri rivers meet, the great city of Cahokia rose, its earthen pyramids towering over a bustling metropolis. And in the shadow of these monumental mounds, archaeologists have uncovered a quieter, more intricate kind of industry, one that dealt not in stone or metal, but in the iridescent lining of a common shell. Scattered across the city, in the remains of what were likely workshop homes, they found the unmistakable signature of mass production. The floors of these structures were not simply dirt, but a dense, glittering carpet composed of millions of tiny fragments of freshwater mussel shell. Mixed into this sea of debris were the tools of the trade, delicate chert microdrills, their tips worn down to nubs from relentless use, and countless unfinished beads in every stage of creation. This was the factory floor for North America's first widespread monetary system. The process was meticulous and standardized. Artisans would first cut a small, rectangular blank from the thick hinge of a mussel shell. Then, using a bow-driven drill much like the carnelian workers of the Indus, they would painstakingly bore a hole through the center of this blank. Finally, the rough cylinder would be ground on a stone against an abrasive paste, slowly rounded into a perfect, smooth, disc-shaped bead, often no larger than a lentil. The volume of waste is what tells the true story. To produce a single strand of beads required the destruction of hundreds of shells and created a mountain of sharp, discarded chips. The workshops at Cahokia contain not just the waste from a few necklaces, but from what appears to be the output of generations. This points to a specialized, full-time craft, an industry organized on a scale large enough to supply a vast trade network. These shell beads were far more than simple decoration. In the complex mound-building societies of the Mississippian world, they were a fundamental form of prestige and stored wealth. A single strand represented weeks of skilled labor, a portable, durable testament to status. Cahokia, as the continent's greatest political and spiritual center, likely controlled the production and distribution of this symbolic currency. Finished beads from Cahokia's workshops have been found in elite burials and ceremonial caches hundreds of miles away, from the Great Lakes to the Gulf Coast. This means that the quiet, meticulous work in those shell-littered houses, the endless drilling and grinding, was the engine for a continent-wide economy of influence, connecting distant communities through a shared language of value, manufactured one luminous, perforated disc at a time. The luminous shell beads of Cahokia were a currency of patience, but another ancient industry would master a far faster kind of magic, turning breath and fire into utility. In the 1st century before the Common Era, along the coast of the Levant, a simple technological spark ignited a revolution in how the world contained itself. Before this moment, glass was a precious material, painstakingly core-formed or cast, its creation slow and its products reserved for the elite. Then, somewhere in the workshops of the Syro-Palestinian region, likely around Sidon, an artisan made a leap. They inserted a hollow metal tube into a gather of molten glass and with a breath inflated it. Glassblowing was born, and with it came the world's first true factories for transparent, functional ware. The archaeological footprint of this revolution is unmistakable. In Jerusalem's upper city and in the industrial quarters of Sidon itself, excavations have uncovered not solitary kilns, but dense clusters of specialized furnaces. These were not the simple ovens of a potter. They were high-temperature tanks designed to maintain large, constant pools of molten glass, the essential raw material for continuous production. Scattered among these furnace bases are the tools of the new trade, fragments of iron blowpipes with glass still welded to their tips, and most tellingly, stone and ceramic molds. These molds are the key to understanding the scale. They are not unique sculptural forms, but standardized negatives for everyday objects, small square bottles for perfumes or medicines, simple hemispherical bowls, and sturdy drinking beakers. A single mold could be used to produce hundreds, even thousands of identical vessels. The process was a paradigm of efficiency. A glassblower would gather a precise amount of molten glass on the end of a blowpipe, inflate it into a basic bubble, and then plunge this hot, pliable form into a waiting mold. A quick puff of air would press the glass against the mold's interior, instantly transferring its shape and any decorative pattern carved into the stone. In seconds, a finished, standardized container was created, where previously it might have taken an hour of careful grinding and polishing. This was assembly line speed applied to a fragile art. The implications were profound. Almost overnight, glass was democratized. What had been a luxury became a common commodity. The Roman Empire, with its vast integrated markets and thirst for practical goods, provided the perfect distribution network. These Levantine factories pumped out endless streams of affordable glass bottles, cups, and storage jars. They shipped them across the Mediterranean, where they became the disposable containers of the ancient world, used in homes, shops, and hospitals from Britain to Egypt. A broken bottle was no longer a tragedy, but a minor inconvenience, easily replaced by another identical one from the next trader's crate. This industrial leap did not just make glass cheap, it changed the very rhythm of daily life, enabling new standards of hygiene, commerce, and convenience, all born from a simple breath of air and a cluster of stone molds by the sea. The democratization of glass transformed everyday life across the Roman world, a quiet revolution in transparency and convenience. Yet another ancient empire understood that to control an economy, you needed to control the very symbols of value to manufacture trust in metal. High on the Ethiopian plateau, the kingdom of Axum grew powerful from its command of trade routes between the Mediterranean and India. But its true industrial nerve center lay on the coast at the bustling port of Adulis. Here, archaeologists have uncovered the physical machinery of an empire's financial authority, a state mint operating on an impressive scale. The remains are not of a single workshop, but a coordinated industrial process laid bare. In one area, you find the foundations of furnaces, their floors still stained with the residue of melted metal. Nearby, there are collections of stone and clay molds, their cavities forming perfect, identical discs, the blank canvases for currency. But the most telling finds are the tools of final authority, the engraved dies. These are pairs of hardened metal stamps, one for the obverse and one for the reverse, intricately carved with the symbols of Axumite power, the ruler's profile, a crescent and disc, or a sheaf of wheat. The process they reveal is a masterpiece of controlled production. First, gold, silver, or copper would be melted in the furnaces and poured into the molds to create stacks of uniform blanks. These plain discs would then be placed between the two engraved dies, and a powerful hammer blow would strike the top die, impressing the royal image onto both sides of the coin simultaneously. This system ensured every coin was a perfect, legal copy, a tiny metal ambassador. The scale of the operation at Adulis speaks to a deliberate, centralized policy. Axum was not merely using coins, it was producing them in volume to a strict standard, flooding its own economy and the wider Red Sea trade network with its official currency. This was a profound tool of control. A merchant in Adulis, a farmer in the highlands, or a trader in southern Arabia would all conduct business using the same familiar coins bearing the king's face. It simplified taxation, stabilized markets, and most importantly, projected Axum's sovereignty far beyond its borders. every transaction became a silent affirmation of the empire's power and stability. The furnaces, molds, and dyes of Adulis were not just making money, they were manufacturing the very idea of a unified economic sphere, an industrial effort where the product was confidence itself. A different kind of workshop thrived in the cold, damp air of Viking ports, its raw material not mined from the earth but shed from the heads of great beasts. In trading towns like Birka and Hedeby, the very ground tells a story of meticulous, scaled-up craftsmanship. Archaeologists excavating these sites don't just find the occasional broken comb. They uncover entire workshop plots that look like the aftermath of a specialized factory's shift. The floors of these spaces are thick with a very specific kind of debris, thousands of sawn-off red deer antler tips, the dense, perfect material for the era's most essential personal grooming tool. Mixed in are piles of half-finished combs at every stage of production, from rough-cut blanks to pieces awaiting their final teeth, alongside the specialized tools that made it all possible: fine-toothed saws, rasps, and polishing stones. This concentration of material in dedicated zones reveals a truth far beyond a single artisan's bench. This was a cottage industry operating on a genuinely industrial scale. The process was a model of efficient batch production. First, the broad, palm-like end of the antler, known as the tres tine, was sawn off. This dense portion was then sliced into flat rectangular plates. Several of these plates would be stacked together, sandwiched between two longer, decorative outer plates, often of more showy bone or even walrus ivory for luxury versions. The entire packet was then riveted together, usually with iron or bronze pins. Only then came the most skilled part, using a fine saw to cut the teeth, a task requiring a steady hand to create dozens of uniform, closely spaced teeth that wouldn't snap. The standardization is evident in the finds, combs of nearly identical size and tooth count, produced in the hundreds, if not thousands, from a single workshop. Why was there such massive demand? In the Viking Age, a good antler comb was not a mere vanity. It was a critical tool for hygiene and pest management, used by men and women alike to maintain long hair and beards. It was durable, portable, and universally needed. A trader in Hedeby could produce or purchase a crate of these combs and know they would be as tradable as silver or fur anywhere around the Baltic or North Sea. These workshops turned a seasonal, renewable resource, shed antlers gathered from northern forests, into a high-value, practical commodity that equipped an entire culture, proving that industry could be built from the most ordinary of needs, one precise, careful tooth at a time. The humble antler comb was a product of open trade, but the most valuable thread in the ancient world was spun under a cloak of imperial secrecy. For centuries, the vibrant, impossibly smooth fabric known as silk was a mystery that traveled west along dusty caravan routes, its origins shrouded in legend. The Roman and Byzantine empires paid staggering sums for it, draining their treasuries to the east. Then, in the 6th century, a story is told of two monks who smuggled silkworm eggs out of China, hidden inside hollow bamboo canes. Whether myth or fact, the result was an industrial revolution confined within palace walls. In the heart of Constantinople, the Byzantine emperors established a new kind of factory, the gynecia. These were not public workshops, but state-controlled industrial compounds dedicated to a single, priceless goal: breaking China's monopoly by manufacturing silk within the empire. Historical records describe these complexes as bustling with thousands of workers, the vast majority of them women, operating under the direct supervision of the state. The entire process, from the delicate care of the mulberry-munching silkworms to the final weaving of the cloth, was contained within this secure environment. This vertical integration was itself a marvel of logistics. In one wing, workers would tend to the trays of worms as they spun their precious cocoons. In another, the cocoons were carefully steamed or dipped in hot water to loosen the filaments, which were then painstakingly unwound and combined into strong, gleaming threads. Finally, master weavers, using immense and complex looms, transformed those threads into the dazzling fabrics that became synonymous with Byzantine power. The security was absolute, the methods a state secret. Leaking knowledge of sericulture, or worse, smuggling out silkworms or eggs, was considered treason, punishable by the most severe penalties the empire could impose. This was not about protecting an artisanal craft. It was about safeguarding a national industry of immense strategic and economic importance. The silk produced in the Gynecia served multiple vital functions. It clothed the imperial court and the clergy in radiant splendor, a visual propaganda of divine favor and unrivaled sophistication. It was also a primary tool of diplomacy, gifted to foreign ambassadors and barbarian kings to awe and pacify them. And crucially, it became a tremendous source of revenue, as the Byzantines could now sell this coveted fabric to the West on their own terms, no longer dependent on the long, perilous Silk Road. The Gynecia were more than factories. They were fortresses of knowledge, where the hum of industry wove threads of gold into the very fabric of an empire's identity and survival. The Byzantine silk factories guarded their secrets within palace walls, but across Asia, another empire's industrial signature was fired in an open, roaring furnace for all to see. In the rolling plains of what is now northeastern Thailand, the landscape of Buriram province is dotted with low, forested hills that hold a surprising secret. These are not natural formations, but the fossilized remains of an ancient industrial park, the backbone of the Khmer Empire's ceramic economy. Scattered across this region are the ruins of massive stoneware kilns, some stretching over 50 meters in length, built in long, sinuous lines up the slopes of hills. Archaeologists call them dragon kilns, and the name fits perfectly, for they resemble great, slumbering beasts of brick and clay. Their design was a masterpiece of thermal engineering, utilizing the natural incline to create a powerful draft. A fire would be lit in the chamber at the lowest, widest part of the kiln, and the heat would race uphill through the long tunnel, passing over and enveloping thousands of stacked pots placed inside before escaping through chimneys at the top. This allowed for incredibly high, consistent temperatures, perfect for vitrifying clay into the hard, non-porous stoneware that was the Khmer specialty. The scale of a single firing is almost difficult to grasp. Each of these dragon kilns could hold tens of thousands of individual items in one go. We are not talking about delicate teacups, but large, sturdy storage jars, cooking pots, and utilitarian vessels, the Tupperware and shipping containers of their day. The logistics alone are staggering. Imagine the workforce required to mine and prepare the clay, to throw or mold this vast quantity of identical forms, to carefully stack every single pot inside the kiln's chamber with precise gaps for the heat to circulate, and then to tend the fire for days on end, maintaining the exact temperature needed. The remains tell this story vividly. The ground around these kilns is not simply dirt. It is a deep, stratified layer of industrial history, composed of ash, broken kiln furniture like stilts and spacers, and most tellingly, enormous mounds of wasters, pots that cracked, warped, or fused together during firing and were discarded on site. These mounds are the undeniable evidence of volume, the acceptable loss from a process operating on an industrial, not an artisanal, scale. This was mass production with a clear imperial purpose. Angkor, the magnificent capital to the south, was a city of perhaps 1 million people, a hydraulic metropolis requiring immense infrastructure. These stoneware jars from Buriram were essential for storing grain, water, and fermented goods, the basic sustenance of a vast urban population. They were also a key trade good, shipped along river networks throughout Southeast Asia, carrying the practical imprint of Khmer civilization far beyond its political borders. The silent, grass-covered dragon kilns of Beroram are a humbling reminder that empires are built not just on temples and conquests, but on the relentless, fiery output of countless humble pots, fired by the tens of thousands in the belly of a clay dragon. The dragon kilns of Beroram fired the sturdy containers of an empire, but in the damp, green hills of southwest Britain, a quieter industry was melting down local resources to set a different kind of table. Across the former Roman province of Britannia, archaeologists keep making a peculiar find, not of precious gold or silver, but of something more modest and telling. Hidden in buried hoards and scattered across ancient shipwrecks in the English Channel, they uncover stacks of pewter plates, bowls, and cups, all sharing nearly identical shapes and sizes. This is not the eclectic collection of a wealthy household, but the standardized stock of a factory, and its source leads directly back to the mineral-rich Mendip Hills. Here, the Romans found a perfect industrial pairing, rich veins of lead for bulk and local tin from Cornwall, which when combined, created a versatile, silvery alloy that could be easily cast. The workshop sites discovered near these mines tell a clear story of organized production. They contain the remains of simple but effective stone molds, often designed to create multiple items at once, and fragments of crucibles stained with the residue of molten metal. The process was straightforward and scalable. A craftsman would pour the liquid pewter into a preheated mold, let it cool, and then break the mold apart to reveal a finished plate, ready for minimal polishing. This method allowed for the rapid production of hundreds, even thousands, of identical items from a single master pattern. But who was buying all this identical tableware? The answer reveals a fascinating social shift. This was not luxury goods for the senatorial elite, who dined on imported silver, nor was it the rough pottery of the poor. This affordable, durable, and attractive metalware was manufactured explicitly for a growing provincial middle class, the successful farmers, veteran soldiers, and local merchants of Roman Britain. Owning a matching set of pewter plates was a tangible sign of Romanitas, of adopting the civilized dining customs of the empire without the exorbitant cost of silver. The hoards themselves, often buried in times of uncertainty, suggest these were valued possessions, the accumulated household wealth of families who had done well under the Roman system. The shipwrecks laden with cargoes of these items show they were traded along the coast, supplying other towns and villas. This Mendip industry is a window into the democratization of Roman culture at its edges, proving that the empire's economic engine included factories that catered not to the palace or the legion, but to the dining room of the aspiring provincial family, turning local British metals into the everyday symbols of a borrowed civilization. The pewter of Roman Britain served a rising middle class, but in the arid valleys of coastal Peru, another civilization's industry was reserved solely for the divine. The moche culture, which flourished between the 1st and 8th centuries, left behind not only vast ceremonial pyramids, but also the precise workshops where they manufactured the very face of authority. At a site called Cerro Mail, archaeologists peeled back the desert floor to reveal a different kind of temple, one dedicated not to worship but to production. Here, they uncovered the complete fossilized process for creating objects of power. The workshop floor was a snapshot of industry frozen in time. Rows of small, efficient furnaces built from mud bricks stood ready, their interiors still blackened from countless firings. Scattered around them were the tools of the metalworker's art, stone anvils, hammerstones, and polishing kits. But the most telling finds were the materials themselves, piles of copper ore, heaps of slag from the smelting process, and most significantly, hundreds of artifacts caught in the act of becoming. These were not finished masterpieces, but the in-between steps, rough castings, half-polished discs, and most strikingly, numerous unfinished ritual masks and crown fragments. These were the sacred regalia of moche elites, the glittering copper faces and headdresses worn by priests and rulers during elaborate ceremonies to communicate with the gods. The presence of so many in a single workshop, all in various stages of completion, points decisively away from occasional craft. This was centralized, specialized, and scaled production. The technique they mastered was lost wax casting, a sophisticated process that allowed for incredible detail. An artisan would first sculpt the desired object, say a mask depicting a deity, in beeswax. This wax model would then be encased in a clay mold and fired, melting the wax out and leaving a perfect hollow cavity. Molten copper, smelted on site in those furnaces, would be poured into the void. Once cooled, the clay mold was broken away to reveal the copper copy of the original wax sculpture. The evidence at Cerro Mail shows this was not a one-off art, but a repeatable, batch-oriented procedure. They likely had master patterns for popular designs, allowing them to produce multiple copies of the same ritual object. The scale of the waste, the slag, and the number of furnaces all speak to a continuous operation, a factory whose sole client was the Moch theocracy. These workshops were the indispensable suppliers to the spiritual and political machine, mass-producing the physical symbols that transformed a human leader into a living conduit for the divine, proving that even the most sacred objects could roll off a well-organized assembly line. The Moch metalworkers forged masks for the gods, but in the cold, rugged landscapes of medieval Norway, an industry was carved from a softer, more domestic stone. Across the fjords and valleys from Trondelag to Telemark, the earth bears the deep, geometric scars of a different kind of factory, one that supplied the hearths of an entire northern world. These are the soapstone quarries of the Norse, and to walk among them is to see a mountainside turned into a production line. The stone itself, steatite, is soft and easily worked when first extracted, hardening with exposure to air and heat, making it perfect for one essential household item, the cooking pot. The quarries are not random pits but organized landscapes of extraction. Vertical cliff faces are marked with the precise, repeating outlines of pot shapes, carved directly into the living rock like giant cookie cutters before being pried loose. These outlines are standardized, often in a few common sizes, revealing that the quarrymen were not sculpting individual works of art, but harvesting identical blanks for mass production. Nearby, the ground is littered with the evidence of this industry, piles of stone debris, half-finished vessels abandoned due to flaws, and the simple stone hammers and iron chisels used to work the material. The scale of removal is immense, with some quarry sites featuring cavernous hollows where thousands of tons of stone were systematically removed over centuries. This was not a solitary craft. The management of these vital resources often fell to a local cooperative district known as a Shrepa, a community-based administrative unit responsible for shared resources like grazing land and, crucially, these quarries. The Shrepa would oversee the fair allocation of quarrying rights, organize the labor, and likely manage the distribution of the finished goods. This system turned a local geological resource into a regional industry. The soapstone blanks, rough-hewn from the cliff, would be transported to nearby workshops for finishing, where artisans would hollow them out, smooth the interiors, and attach iron wire handles. The final products, those iconic three-legged cooking pots, were incredibly durable and excellent at retaining heat, making them far superior to ceramic pots for the long, slow simmering of Norse stews over an open fire. But their reach extended far beyond the local fjord. These standardized soapstone pots became a staple export, found in Viking-age settlements from Dublin to Newfoundland. They were ballast in ships, trade goods, and essential equipment for settlers establishing new homes across the North Atlantic. Every pot, from the quarries of Norway to a hearth in Iceland, speaks of a decentralized yet highly organized industrial system, where communities collaborated to literally carve out the necessities of daily life, turning soft stone into the hard, practical backbone of a culture's domestic economy. The soft stone of Norse hearths gave warmth to a home, but in the thin, high air of the Andes, an empire wove its power from threads of light. In the heart of the Inca capital, Cusco, stood walled compounds known as Aclawasi, the houses of the chosen women. To the outside world, these were sacred spaces, home to the Aclas, women selected from across the empire for their beauty and lineage to serve the sun god in Tyre and the emperor, the Sapa Inca. Their lives were dedicated to ritual, but also to a form of devotion expressed through relentless, precise industry. Within these secluded courtyards, the chosen women operated the most important textile factories in the Americas. The evidence lies in the architecture itself and the tools left behind. These were not small household rooms, but large, open halls designed to accommodate rows of standardized backstrap looms, all anchored to stone hooks still visible in the walls. This setup allowed dozens of weavers to work in unison, their movements synchronized, their output multiplied. The product was campi, a cloth of such extraordinary fineness that the Spanish conquistadors mistook it for silk. Creating it was an act of supreme skill and patience, using the finest fibers from vicuña, the wild relative of the alpaca, whose wool was reserved exclusively for royalty. The process was a state-mandated craft with patterns and colors strictly codified. Certain geometric designs, like the tukapu, functioned almost as a heraldic language, communicating status, lineage, and affiliation through woven symbols. This was not artistic improvisation, it was the mass production of identity. The scale of the operation within the Aclawasi was immense, designed to meet the insatiable demands of the imperial economy. Every thread had a destination. The finest campi cloth was presented as the ultimate state gift, a tangible piece of imperial favor given to loyal provincial lords and allied rulers, binding them to Cusco with a fabric more valuable than gold. It clothed the Sapa Inca and the royal Panoka, their families, in radiant splendor during public ceremonies. It also equipped the military, providing standardized tunics and cloaks that visually unified the Inca army, turning soldiers into a cohesive, moving tapestry of imperial power. And it was essential for every major ritual, used to wrap sacred mummies, dress idols, and make sacrificial offerings. The chosen women, therefore, were far more than priestesses. They were the highly skilled operators of a state-run factory, their secluded labor transforming the soft fleece of mountain animals into the very fabric of empire. Their looms were engines of diplomacy, administration, and faith, weaving soft threads into unbreakable bonds of control. The looms of the Aclawasi wove power from soft vicuña thread, but another ancient industry manufactured the very medium of thought itself. In the fertile, marshy expanse of the Nile Delta, an empire of reeds grew, and from it, the Hellenistic world built its first true information economy. Papyrus was not merely a plant, it was the paper of antiquity, the essential substrate for every contract, poem, decree, and scroll that flowed from Alexandria to Rome. To produce it required not a craft, but a meticulously organized factory process, one so effective its secrets remain partially hidden, pieced together from passing mentions in texts and the rare, waterlogged clues preserved in the delta's mud. The entire operation began with the rhythmic harvest of the tall, triangular cypress papyrus stalks, cut by the thousands from the choked waterways. This was an industry built on a renewable resource, but one that demanded precise timing and coordinated labor. The next steps, inferred from scattered descriptions by writers like Pliny the Elder, reveal a production line as deliberate as any modern assembly. Workers would slice the fibrous pith of the fresh stalks into thin, vertical strips. These strips were then laid side by side, slightly overlapping on a hard, wet board. A second layer of strips was placed crosswise on top, at a 90-degree angle, creating a crude lattice. The genius of the process was in the bonding. The natural starches in the papyrus itself acted as a glue. The layered sheet was then soaked, pressed under heavy weights for days, and finally hammered smooth and left to dry in the sun. What emerged was a single, strong, flexible sheet with a smooth writing surface. But a single sheet was useless. The true factory product was the roll or scroll. Artisans would join these individual sheets together with a paste made from flour and water, creating continuous rolls, often 20 or even 30 sheets long, which were then wound around a central wooden rod. The scale implied by historical demand is staggering. Think of the Great Library of Alexandria, aiming to collect a copy of every known scroll. Think of the sprawling Ptolemaic bureaucracy in Egypt, recording every land survey, tax receipt, and grain shipment in duplicate. Think of the export trade, shipping blank rolls to every scholar, merchant, and administrator across the Mediterranean. This demand could only be met by an organized, high-volume industry. The factories were likely open-air complexes along the canals, with dedicated areas for each stage: harvesting, slicing, soaking, pressing, drying, and pasting. The work was surely divided among teams, some specializing in the initial cutting, others in the delicate layering and pressing, and still others in the final assembly and quality inspection. A flawed sheet with gaps or weak spots would snap under a scribe's pen, so consistency was paramount. This was mass production for the mind. Every philosophical argument from Athens, every love poem from Rome, every administrative order from a Ptolemaic official was inscribed on a material produced through this systematic Egyptian factory process. The papyrus roll was the ancient world's hard drive, its cloud storage, and its publishing house, all rolled into one, and its manufacture was the first great industry dedicated not to things but to ideas. The papyrus factories of Egypt mass-produced the medium for words, but in the heart of ancient Mesopotamia, an empire perfected the art of mass-producing its own story in stone. The Assyrian kings of Nineveh did not simply build palaces. They manufactured a permanent, overwhelming narrative of their power, and the workshops that made this possible left behind a clear industrial blueprint. The evidence begins far from the capital, at the quarries near Mosul. Here, workers extracted immense blocks of fine, creamy alabaster, a relatively soft stone ideal for carving. The blocks were not cut to random dimensions. Archaeological study reveals they were systematically quarried to a remarkably consistent thickness, often around 25 centimeters. This standardization was the first critical step in an assembly line process, ensuring every panel that arrived at the palace workshop was a uniform blank canvas, ready for the sculptor's team. Inside the palaces themselves, like the magnificent North Palace of Ashurbanipal, the scale of the finished product is staggering. Gallery after gallery was lined from floor to ceiling with these carved slabs, creating a continuous, immersive visual epic that stretched for hundreds of feet. To cover such vast areas with such intricate detail required more than a few master artists working for years. It demanded a factory of sculptors. The tool marks left on unfinished panels and in workshop areas tell this story of organized parallel production. You can see how different sections of a single relief were carved by different hands, some specializing in the deep, muscular outlines of horses and lions, others in the fine details of feathers, jewelry, or the cuneiform inscriptions that narrated the scenes. This division of labor allowed for incredible efficiency. Imagine a long wall in the palace being prepared. Teams of masons would first secure the standardized slabs into place. Then, master designers would sketch the grand composition directly onto the stone with charcoal or paint. Following these guidelines, groups of sculptors would move down the wall simultaneously, each working on a specific panel or a specific element within a panel, their chisels ringing in a coordinated symphony of stonework. The subjects were strictly controlled, a relentless propaganda of imperial might. Scenes of the king hunting lions demonstrated his courage and divine favor. Panoramas of armies besieging cities and processing prisoners showcased his military invincibility. Every panel was a piece of a larger message, designed to awe visiting dignitaries and intimidate anyone who might challenge the throne. The sheer volume is the final proof of its industrial nature. To produce thousands of square meters of such detailed relief sculpture within the reign of a single king was a logistical and artistic feat comparable to a modern film studio producing a blockbuster. It was an industry of imagery where the raw material was quarried stone and the finished product was unquestioned authority, carved into the very walls of the empire. The stone reliefs of Assyria were a fixed and permanent record of power, but another kind of industrial rhythm pulsed through the forested valleys of medieval Europe, powered not by royal decree, but by the simple, relentless force of gravity. Deep in the Cévennes mountains of southern France, the streams tell a quieter, more mechanical story. Here, the archaeological remains are not of palaces or temples, but of elegantly simple machines built into the landscape itself. Along the banks of certain rivers, you can still find the moss-covered stone foundations of waterwheels, set in a deliberate series, one after another. These are not the wheels of picturesque mills grinding grain, but the driving hearts of early industrial forges. This was the medieval world learning to harness nature's pulse to multiply human strength on an unprecedented scale. The system was a marvel of practical engineering. A stream would be partially diverted into a narrow, built-up channel called a leat, which directed the flow onto the paddles of a large vertical water wheel. The wheel's axle was connected to a series of cams or wooden pegs. As the wheel turned, these cams would sequentially lift heavy wooden trip hammers, only to release them, letting them fall with a tremendous, rhythmic blow onto an anvil or a piece of red-hot iron placed below. Imagine the soundscape of such a place, the constant rush of water, the creak of timber, and the deafening, regular crash of hammers striking iron, a sound that could echo through the valley day and night without a moment's rest from human fatigue. This mechanization changed everything about iron production. Before this, forging a bar of iron or shaping a tool required a blacksmith to lift and swing a heavy hammer, a laborious process limited by human endurance. The water-powered trip hammer never tired. It could deliver hundreds of identical, powerful blows per hour, working a bloom of iron into a uniform bar with a consistency no human arm could match. The archaeological sites show these forges were organized for continuous output. Upstream, charcoal burners would have worked the forests to fuel the smelting furnaces that produced the raw iron blooms. The blooms would then be brought to the forge, where the trip hammers would beat out the slag and shape the metal. Downstream, other workshops might specialize in finishing the bars into specific tools like plowshares, axes, or nails. This sequential use of water power with multiple wheels along a single stream represents a primitive but brilliant production line. The output was not for grand monuments, but for the essential tools that built medieval society. The iron bars and agricultural tools produced in these mountain forges supplied growing towns and cleared vast tracts of forest for farmland. This was industry in the service of expansion and daily survival. The Cévennes forges stand as a quiet but profound turning point. They demonstrate that the core principle of the Industrial Revolution, the use of inanimate power to drive machinery for mass production, was not an 18th century invention, but a logical step that medieval minds had already taken centuries before. They heard the rhythm of the river and built a hammer to match its beat, forging the very sinews of their world with a force borrowed from the mountains themselves. The rhythm of water-powered hammers shaped the tools of medieval Europe, but on the most isolated inhabited island on Earth, an entire society directed its industry toward a single, staggering purpose. The volcanic crater of Ronoroku on Rapa Nui, or Easter Island, is not merely an archaeological site. It is a factory floor frozen in time, a landscape entirely dedicated to the mass production of giants. To stand on its slopes is to walk through a snapshot of a centuries-long industrial process suddenly halted. The soft volcanic tuff of the crater's inner and outer walls is not simply rock, it is a matrix of half-formed figures. Hundreds of the iconic Moai statues are embedded here, caught in every conceivable stage of creation. Some are just faint, ghostly outlines, mere sketches carved into the cliff face, marking where the next colossal form would be extracted. Others are partially freed, their heads and shoulders emerging from the living rock while their backs remain fused to the mountain. Still others lie fully carved and detached, resting on the slopes as if awaiting transport, their features crisp and complete. This density and variety is the unmistakable signature of a sustained, organized industry, not a sporadic artistic endeavor. The quarry itself reveals a systematic extraction technique. Carvers did not simply hack at the rock. They first cut a narrow, deep trench around the outline of a statue, then patiently worked to undercut it, freeing the figure from the bedrock until only a narrow keel of stone along its spine kept it in place. This keel would be the final cut, allowing the statue to be carefully lowered down the slope. The ground is littered with thousands of stone picks called toki, made from a harder basalt, the standardized tools of this monumental trade, discarded and replaced as they wore down. The logistics implied are profound. This was a continuous, multi-generational project. The scale of unfinished work suggests a highly specialized workforce, with different groups responsible for different stages: quarrying, carving fine details like the elongated ears and delicate hands, and finally preparing the figures for their journey across the island. The industry was central to the island's culture and social structure, a physical manifestation of clan identity and ancestral veneration. Each moai, once erected on a coastal platform, was a permanent, watchful presence, a conduit between the living community and the spirit world. The sheer number of statues, nearly 900 known to exist with almost 400 still in the quarry, speaks to a society that channeled a significant portion of its energy and ingenuity into this single, unifying output for centuries. The factory at Ronoroku did not produce goods for trade, for it had no one to trade with. Instead, it manufactured the very soul of the island, carving its beliefs and social order directly from the heart of a volcano. The silent, watchful giants of Rapa Nui were a society's entire industrial output, but the most refined factories of the ancient world were designed to serve a single, living court. In the red sandstone city of Fatehpur Sikri, built by the Mughal Emperor Akbar in the 16th century, the grand palaces and courtyards are only half the story. Tucked discreetly into the city's geometric plan are the remains of a different kind of power center, the imperial Karkhanas. These were not mere clusters of artisans, but a highly organized, state-controlled industrial complex, a factory system dedicated to manufacturing the very aura of an empire. The layout itself reveals their purpose. Separate, purpose-built workshop blocks were assigned to specific, elite crafts. One complex was dedicated solely to the intricate art of jewelry, where master lapidaries cut emeralds from the New World and polished diamonds from Golconda. Another block housed the arms manufactory, where teams of smiths forged and damascened fine blades, and craftsmen inlaid gun stocks with ivory and gold. A separate quarter was reserved for textile production, with rows of looms for weaving the impossibly fine muslins and brocades that defined Mughal luxury. Nearby, scriptoriums hummed with the quiet work of calligraphers, illuminators, and bookbinders, producing lavish manuscripts that were works of art in themselves. This physical separation by specialty is a classic hallmark of industrial organization, designed for efficiency and strict oversight. The Karkhanas were far more than studios. They were state-run factories with a clear chain of command. A high-ranking official, the Darogha, supervised each workshop, managing inventories of precious raw materials, from Central Asian silver to Chinese silk threads, and enforcing exacting standards. Every item produced was logged, its cost calculated, and its quality inspected before it could enter the imperial treasury. This system of accountability ensured that nothing left the Karkhana unless it met the emperor's personal standard of perfection. The scale of production was calibrated to the insatiable needs of the court, which functioned as a small, mobile city of thousands, all requiring clothing, armor, ceremony, and gifts. But the output of these workshops served a purpose far beyond mere supply. Each finely crafted object was a political instrument. A jeweled dagger was not just a weapon, it was a gift to a restless noble, a tangible reward binding him to the throne. A bolt of gold-embroidered cloth sent to a foreign ambassador was a display of unimaginable wealth and sophistication, a form of soft power that could awe potential rivals. The luxurious manuscripts reinforced the emperor's image as a patron of culture and divine wisdom. The Karkhanas were, in essence, a propaganda machine, but one that spoke in the language of exquisite craftsmanship rather than loud proclamations. They translated the empire's vast economic resources into a visual and tactile language of authority, producing luxury not as an indulgence, but as the essential currency of rule. In the quiet, sunlit ruins of these workshop blocks, one can almost hear the disciplined click of looms and the soft scrape of polishing stones, the sound of an empire carefully constructing its own magnificent image, piece by perfect piece. These scattered workshops, from the shell middens of Tyre to the assembly lines of the Kin, are not isolated curiosities. Together, they form a constellation, and when we step back to view the entire sky, clear patterns emerge, revealing the true architecture of ancient production. The first and most telling pattern is standardization. Whether it is the interchangeable bronze triggers of the Chinese crossbow, the identical red glazed bowls from Arezzo, or the perfectly uniform carnelian beads of the Indus, we see a relentless drive toward the repeatable unit. This is not the signature of an artist seeking unique expression, but of a system seeking efficient output. Standardization is the prerequisite for everything that follows, the key that unlocks scale. That scale is made possible by a second universal pattern, the specialization of labor. The evidence never points to a single craftsperson completing an object from start to finish. Instead, we see a deliberate fracturing of the process. In the Roman brickyards, one team mined clay, another formed the bricks, a third fired them, and a separate clerk applied the stamp. At the Moch metalworking site of Cerro Mail, some focused on smelting ore, others on lost wax casting, and still others on the final polishing. This division of labor is a powerful cognitive tool. It allows individuals to develop extreme proficiency in a single, repetitive task, dramatically increasing the speed and consistency of the overall output. It transforms a craft into a procedure, and where there is procedure on a grand scale, there is always a third, more silent witness: large-scale waste. The mountains of crushed murex shells, the glittering carpets of obsidian flakes at Teotihuacan, the deep strata of broken pottery wasters around the Khmer dragon kilns, these are not signs of failure. They are the inevitable byproduct of volume. This waste is the archaeologist's most honest ledger. It quantifies ambition. A solitary artisan generates little debris, but a factory, running day after day, year after year, creates its own geological layer, a permanent record of relentless activity. This activity required space, leading us to the fourth pattern: organized workspaces. These were not random areas where work happened. They were engineered for flow. The perfume factory at Pyrgos had separate zones for distillation, mixing, and storage. The fullery in Pompeii channeled water through a sequence of vats in a strict cleaning order. The papyrus makers of the Nile Delta likely had designated areas for harvesting, slicing, pressing, and pasting. The layout itself was a form of technology, a physical algorithm designed to move material and people through the production process with minimal friction. Finally, who orchestrated these complex systems? The pattern here points overwhelmingly to control. This was rarely free market enterprise. More often, it was the state or a powerful elite that provided the capital, the security, and the command structure. The Kin emperor's armories, the Byzantine silk gynecea, the Inca Aklawasi weaving workshops, and the Mughal Karkhanas were all direct extensions of royal authority. Their purpose was dual: to supply the needs of the ruling apparatus and to produce the symbols, from purple dye to golden cloth, that made that authority visible and tangible. Even in less centralized contexts, like the Norse soapstone quarries managed by a local Hrepper, we see community-level organization directing a shared resource toward common economic goals. When we hold these 5 patterns together, standardization, specialization, waste, organized space, and control, a profound truth comes into focus. The romantic image of the solitary ancient artisan, lovingly crafting a one-of-a-kind object, tells only a tiny part of the human story. For millennia, alongside that individual creator, there hummed a different engine. Societies across the globe independently discovered that by breaking down complex tasks, standardizing outputs, and organizing labor within a controlled framework, they could achieve something transformative. They could manufacture abundance. They could produce not just for a village but for a city, not just for a chief but for an empire. The logic of the factory, the very heart of what we call industry, is not a modern invention. It is an ancient, recurring human discovery, a pattern etched not only in clay and stone, but in the deep structure of our collective past. The workshop was the cradle of civilization long before it became the engine of our modern world. These patterns of production left a permanent signature on the earth, one we can still read in the landscape today. The legacy of these ancient factories is not just in the objects they made, but in the profound, physical changes they wrought upon their surroundings. To walk these sites is to witness a dialogue between human ambition and the planet, written in stone, soil, and silent ecological memory. The most direct evidence is often the most monumental, the vast spoil heaps that shadowed these industrial centers. Think of the Phoenician middens, those artificial mountains of crushed sea snail shells that still rise from the Mediterranean coast, or the sprawling black mounds of obsidian waste at Teotihuacan, glittering testaments to millions of strikes. In Britain, the Roman lead and silver mines of places like Charterhouse left behind great, barren hills of sterile rock and processing slag, landscapes so altered they were given names like the Rakes. These are not natural features, they are the direct physical output of consumption, the discarded shell of industry piled high and left for centuries. They quantify in a visceral way the staggering volume of material that passed through these systems. To create that volume required fuel, and that demand reshaped entire ecosystems. The roaring furnaces of the Song Dynasty ironworks consumed forests. To produce the tens of thousands of tons of iron they achieved annually required a corresponding mountain of charcoal, which meant the systematic harvesting of woodlands on a scale that would have visibly changed the region's ecology over time. The same story unfolded around the Khmer dragon kilns, where firing tens of thousands of pots in a single cycle demanded immense, sustained heat, turning nearby forests into managed fuel plantations. This consumption was a form of terraforming, a slow re-engineering of the local environment to feed the industrial appetite. The impact often flowed downstream, literally. The ore-washing floors of the Laurion silver mines required enormous quantities of water, channeled and diverted from natural courses. the chemical process of separating silver from lead ore left behind toxic tailings, residues of heavy metals that washed into the soil and the sea, a form of ancient industrial pollution that persists in the sediment layers to this day. In Rome, the noxious runoff from the fulleries, laden with urine and chemical agents, would have seeped into the groundwater and local streams, an accepted cost of urban cleanliness. Perhaps the most dramatic alterations are the quarries themselves. The soapstone pits of Norway are not just holes in the ground, they are negative sculptures, entire hillsides carved into a geometric honeycomb of extraction. The alabaster quarries of Assyria and the great statue factory of Rono-Roroku on Easter Island are landscapes fundamentally remade by human purpose, their cliffs bearing the ghostly outlines of what was taken, a permanent record of removal. These environmental scars are a crucial, often overlooked form of evidence. They tell us that the scale of these operations was not abstract. It was a physical force that demanded space, consumed resources, and generated waste on a level that permanently marked the land. This long-term footprint connects the ancient industrialist to the modern planner. It reminds us that the challenge of balancing production with environmental stewardship is not a new dilemma, but a very old conversation between civilization and its home. The silent, altered landscapes are the final testament, proving that these were not temporary workshops, but enduring forces that shaped the world in their image, leaving a story in the very bones of the earth. This repeated discovery across time and space forces a fundamental shift in perspective. The steam engine did not invent mass production, it merely gave it a new and faster heartbeat. Long before coal smoke darkened the skies, human societies had already mastered the core principles of industrial logic. They achieved staggering scale through meticulous organization, relentless specialization, and audacious resource management. The 30 workshops we have explored are not bizarre anomalies or lucky accidents. They are representative examples, a scattered but undeniable sample of a widespread economic reality. From the desert to the jungle, from island quarries to imperial capitals, the pattern emerges again and again. When a society needed to produce something in vast quantities, whether it was purple dye, iron tools, or sacred statues, it did not simply ask its artisans to work harder. It redesigned the very process. It broke the task into steps, assigned specialists to each stage, standardized the output, and managed the flow of materials with a commander's eye. This was not magic, it was management. It was the ancient blueprint for abundance. To study these silent workshops is to deepen our understanding of ancient complexity in the most tangible way. It moves us beyond kings and battles, beyond art and temples, into the humming engine rooms that made those glorious surfaces possible. It reveals our ancestors not as primitive figures, but as sophisticated logisticians, engineers of supply chains, and directors of human effort. Their legacy is written in crushed shell and slag heaps, in identical pottery shards and mountains of stone waste. And if these 30 sites have survived to tell their tales, it begs a thrilling question. How many other lost industries still lie hidden beneath our feet, their stories waiting to be unearthed by a curious trowel or a scanning satellite? The ancient world was not a quiet place of simple crafts. It was, in countless forgotten corners, a landscape of coordinated fire, organized motion, and silent, purposeful scale.